Yes friends, good morning and welcome to lecture number 2 of maths optional. Okay, this is lecture number 2 of maths optional paper 1. Okay, regarding the first lecture, as I have already told you that the first lecture I didn't tell much in the first lecture, no need to watch it. Okay, it was kind of notification only, kind of announcement only, so no need to watch the first lecture. You can surely watch from the second lecture. And this lecture series is meant for those people who have maths as their optional subject. Okay, already my physics optional series is going on and the response was great, but I also want to launch the maths optional course now, because there was a lot of gap in between. So I will also make videos of maths optional, and there will be 100% coverage of syllabus for maths optional as well. Okay, and the way physics optional is going on, the same way maths optional will also go on. Okay, and this paper 1 consists of 180 lectures. Okay, there will be 180 lectures of maths optional paper 1, and in the lecture number 1 I have told you the overall introduction, and I have also told you in the first lecture about myself, what is my educational qualification and etc. So if you are interested, then you can surely watch the first lecture as well, but there hasn't been taught much in that lecture. So only the definition of matrices I had told in the first lecture. Now in this lecture we are going to start the actual concept of maths optional paper 1 first topic, which is matrices. Okay, so as told in the first lecture, I had only covered up to here only. This definition only I had covered. Okay, after that I didn't do anything. So it was only 14 minute duration lecture. Okay, but this lecture is going to be longer. Okay, so matrices definition, as told in the first lecture, any system of mn elements. Okay, why mn elements? Because there will be m rows and n columns. Okay, there will be m rows and n columns. Okay, so you can clearly see over here that there are m rows. Okay, there are m rows and there are n columns. Okay, so any system of m rows and n columns, okay, arranged in a rectangular array. Okay, arranged in a rectangular array. What does it mean by rectangular array? You can clearly see this, that what is the difference between square and rectangle? That if suppose m equal to n, okay, means the number of rows equal to number of columns, suppose, then it will become a square matrix. Okay, it will become square matrix because square has both the sides equal. Okay, both the sides are equal for a square, this side also and this side also. Length and width are same for a square, but for a rectangle, length and width are different. Okay, so every rectangle is a square. Okay, sorry, every square is a rectangle. Okay, it is said like this, that every square is a rectangle, because a square is just a special case of rectangle. When both the side, that is the length and breadth of the rectangle, become equal, then it forms a square. So every square is a rectangle in itself. Okay, so in order to keep the statement general, I have defined it like this, that any system of mn elements. Why mn elements? Because you can clearly see this thing, that there are m rows and n columns, so mn elements will be there. When I arrange the elements like this, okay, suppose I arrange the elements like this, then clearly if I ask you the number of dots over here, if I ask you the number of dots over here, you will simply measure these 3 and you will measure these 4, and you will say 4 into 3 is the number of elements. Okay, so similarly the same concept holds for matrices as well. Okay, so any system of mn elements arranged in a rectangular array, rectangular array of m row and n columns. Okay, there will be m rows like the one given over here. Okay, m rows, and there will be n columns. Okay, so mn elements will be there. Okay, so that's why mn elements arranged in a rectangular array of m row n column is called a matrix. Okay, this is called a matrix. And what is the difference between a matrix and a determinant? You will have to wait for that. That concept is going to come in future, that what is the difference between a square and a rectangle. Not square and rectangle. What is the difference between matrices and determinants? That is going to come later on. Okay, it will come in the future. So in generalized manner, we can write it like this, right? And I had already told you that in all these elements which are there in the horizontal rows, in all these elements, the subscript remains as it is. So the initial subscript, that is the M subscript, okay? This subscript in the initial, okay, AMN, okay? So initial subscript, if I say AIJMN, okay? So initial subscript is I, and letter subscript, second subscript is J. So this I remains constant for horizontal things, for horizontal rows, that is the horizontal arrangement. For horizontal arrangement, this I remains constant, and for vertical arrangements, what will happen? For vertical arrangements, as shown in the figure, for vertical arrangements, your J will remain constant. Okay, for vertical arrangement, J will remain constant. For vertical arrangements. So you can clearly see this thing from this figure. It is quite evident from the figure. Okay. So Aij M cross N is the notation which is used to denote a matrix. Okay. So let's move on. Now what is a square matrix? I already told you that every square is a rectangle in itself. So when length and breadth of a rectangle become equal, so a square is a special case of rectangle. So what will it mean by square matrix then? A matrix A equal to Aij is called a square matrix. It will be called a square matrix if number of row equal to number of column, that is M equal to N. It is quite evident from here. Let us assume that M and N value become equal. Okay, let us assume that M and N value become equal. Then what will happen? The same number of rows will be there and same number of columns will be there, right? Same number of rows will be there and same number of columns will be there. So if suppose I have a situation like this, that this rectangular arrays look something like this, then the number of rows and number of columns both are equal. So it will look like a square. But if they are unequal, then what will it look like? It will look something like this if they are unequal. Okay, if they are unequal, then it will look something like this. Okay, because you can clearly see here that 4 rows are there but only 3 columns are there, but over here both are 3 and 3. So when both become the same, then it will be square. Okay, so over here if I will write, if M equal to N, okay, if you write over here that M is equal to N, okay, then it will become a square matrix clearly. Okay, so square matrix, a matrix A equal to Aij is called a square matrix if number of row equal to number of column, M equal to N. Now you can clearly see this, that this is 2 by 2 square matrix. This one is 2 by 2 square matrix. And what is this? This is 3 by 3 square matrix. The other one which has been written, okay, like the one given over here, this is 3 by 3 square matrix. Okay, so square matrix is defined like that. Okay, so your second heading is over. Now we will move on towards our third heading. Okay, null matrix or zero matrix. Now what does it mean by null matrix or zero matrix? So clearly a matrix A equal to Aij is called a null matrix or zero matrix. Okay, it is called a null matrix or zero matrix if all the elements of the matrix are equal to 0. Okay, all the elements should be equal to 0, but it is not compulsory that it will be a square matrix. Okay, just remember this thing. If all the elements, like the one I showed in the previous slide, like all these elements, okay, this also 0, this also 0, this also 0, 0, 0, 0, 0, 0, 0, okay, all elements are 0 only, all the Mn elements are 0. Okay, and all these intermediate elements are also 0. So everything is 0 only, no other elements except 0 is there. Okay, so a matrix A equal to Aij is called a null matrix or zero matrix if all the elements of the matrix are equal to 0. Okay, that is Aij equal to 0. And what does this symbol mean? This symbol implies for all. Okay, For mathematics optional students, this symbol will come again and again. This symbol basically means for all. Okay, so aij equal to 0 for all I and j. Okay, for all I and j, aij equal to 0. Okay, so clearly the examples of null matrix are given over here. Okay, you can clearly see this, that a equal to 0 0 0 0, this is 2 by 2 null matrix, and this is 2 by 3 null matrix. Why 2 by 3? Because 2 rows and 3 columns, so the number of rows will be written first. So 2 rows are there, so 2 cross 3. Now don't ask me why not 3 cross 2. Okay, someone will ask me that why not 3 cross 2. It is a convention. It is a convention that we take number of rows first and number of columns later. Okay, we take number of rows first and number of column later. This is a convention. So instead of 3 by 2, we write 2 by 3. Okay, so it is a convention. No one can ask that why this convention was chosen. No one should ask that. Okay, it is not a question worth asking. Okay, so you have to note this thing very well, that a null matrix is not necessarily a square matrix. Okay, just remember this thing. Students get confused over here. I have seen a lot of students making this mistake, that they consider null matrix to be a square matrix only always, but it is not compulsory, as is evident over here. The matrix B is not a square matrix, yet it is a null matrix. Okay, matrix B is not a square matrix, it is a rectangular matrix. It is a rectangular matrix, yet it is a null matrix, right? So null matrix is not necessarily a square matrix. Just remember this thing and note it down in your notebook. Now what does it mean by diagonal matrix? Okay, a square matrix A equal to aij is called a diagonal matrix. It will be called a diagonal matrix if all the elements other than the principal diagonal are equal to 0. Okay, now what does it mean? First of all, we will have to understand the meaning of principal diagonal. Okay, so suppose I have a matrix written over here, something like this. Okay, I have a matrix something like this. So what is this matrix? It is basically your 5 cross 4 matrix, right? It is your 5 cross 4 matrix. So what will be its principal diagonal? So clearly a situation of this kind, okay, a situation of this kind will be called as diagonal matrix. Now you can clearly see over here that this one, okay, this will be your principal diagonal over here. Okay, this will be your principal diagonal. The diagonal which starts from the first element and goes like this. Okay, that will be your principal diagonal. Okay, so over here in this figure I have written big zeros. So what does it mean by these big zeros? These big zeros just mean that it is like this. Okay, let me write over here properly. What does this big zero mean? Okay, so you can see this clearly, that these big zeros clearly mean that it is some situation of this kind. Okay, it is a situation of this kind. So this will be your principal diagonal. Okay, so whenever I write a big zero, that means that all the elements other than the diagonal, principal diagonal, are equal to 0. So principal diagonals look something like this. Okay, principal diagonal or leading diagonal. Okay, principal diagonal, leading diagonal. Okay, it is also called as leading diagonal. So a square matrix A equal to aij is called as diagonal matrix if all the elements other than the principal diagonal are equal to 0. Okay, so all other elements are equal to 0 except the principal diagonal. Okay, and what are the further specifications of it? Further space, and all the diagonal elements are distinct also. This is also a requirement. Okay, just underline this, that even if suppose we have something of this kind. Suppose over here it is not 1 2 3. Suppose instead of 1 2 3 we have 2 2 2. Suppose we have 2 2 2. Okay, then what will happen? All the diagonal elements are not distinct. Okay, as all the diagonal elements are not distinct, so it will not be a diagonal matrix. It will not be a diagonal matrix. Why? Because you can take 2 common out of this. Okay, because you can take 2 common out of this. Okay, so it will yield you some other matrix. Okay, which will come later. Identity matrix it is going to yield you. Okay, so basically all the diagonal elements are distinct. This is also a necessary requirement. Many students don't know this. Okay, so for a matrix to be diagonal matrix, all the diagonal elements should be distinct is also a requirement. Okay, so if all diagonal elements equal, then scalar matrix. Okay, if all the diagonal elements become equal, okay, if all the diagonal elements become equal, like the case I had told you over here, like the case I had told you over here, that all the diagonal elements become equal, 2, 2 and 2, then it becomes a scalar matrix. Okay, it becomes a scalar matrix. It no longer remains a diagonal matrix. And if all are equal, and unity also, okay, if all of these elements are equal, suppose, okay, but instead of 2, 2, 2, we have suppose 1, 1 and 1. Okay, instead of 2, 2, 2, we have suppose 1, 1 and 1. Then what will happen? It will be clearly identity matrix. Okay, so identity matrix has specific properties which we are going to learn in the upcoming classes. Okay, so you will have to wait for a while in order to all concepts get clear. Okay, so scalar matrix. Now we will learn about scalar matrix. A diagonal matrix is said to be scalar matrix, as told just before. Over here just additional definition has been written. Okay, additional definition has been written over here, that's it. Okay, so a diagonal matrix is said to be scalar matrix if all the diagonal elements are equal but not equal to unity. Okay, so it is quite obvious now that suppose I have a matrix of this kind. Okay, and suppose all the diagonal elements are equal, 2, 2 and 2. Okay, 0, 0, 0, 0, 0, 0. Okay, like this it is. So all the diagonal elements are equal but not equal to unity. If they will be equal to unity, okay, if they will be equal to unity, then what will happen? It will be identity matrix. Okay, so that's why not equal to unity. And why scalar matrix? Because all the diagonal elements are equal. Okay, so diagonal matrix is said to be scalar matrix if all the diagonal elements are equal but not equal to unity. Okay, just bear this thing in mind. Okay, so this thing must be very, very clear to you. Okay, now we have other definition also. We have other definition also for a scalar matrix. A square matrix. Okay, a square matrix A equal to Aij is called a scalar matrix if, okay, it is called a scalar matrix if A equal to Aij, and it is equal to A if I equal to J, A is not equal to 1. Okay, and equal to 0 if I is not equal to J. Okay, so a square matrix A equal to Aij is called a scalar matrix. When will it be called as a scalar matrix? Because you can clearly see this thing that A11, A12, A13, suppose it is situation of this kind, then A21, A22, A23. Okay, then finally you have A31, A32, A33. Okay, so if I is equal to J, okay, that is for these elements I is equal to J, right? For these elements I is equal to J. So if I is equal to J, then what will happen? A is not equal to 1, that is these elements are not equal to 1, but I is equal to J for all these elements, principal diagonal elements, so it will be equal to A, which is not equal to 1. Okay, and 0 if I is not equal to J. For all these elements I is not equal to J, as is seen over here, this element. Okay, let me show you with a different color. this element, this element, this element, this element, this element, this element. Okay, all these elements are off diagonal elements. So for these off diagonal elements, I is not equal to j. So for I is not equal to j, the value has clearly come out to be equal to 0. Okay, so all these elements are 0 basically. Okay, only these elements are equal to a, only these elements are equal to a, and in that too a is not equal to 1. Okay, except 1, everything is allowed. Got it? So these are the some of the examples. Okay, these are some of the examples. A equal to 2 2 2 0 0. Okay, you can see over here a equal to 2 2 2 0 0. This 0 0 simply means that it is a situation like this. Okay, this big 0 simply imply this thing, and this is the case. Okay, so clearly these elements are not equal to 1. Clearly these elements are not equal to 1, and if they would have become 1, then it would have become identity matrix. If they would have become 1, if they come out to be equal to 1, then it would become an identity matrix of this kind. Okay, but as they are not equal to 1, so it is a scalar matrix, and only principal diagonal elements are existing. Okay, so what does this mean? 2 4 6 0 0 0 0 0 0. Suppose it is like this, then it will be a diagonal matrix, because the elements are not equal and only diagonal elements are present, so it will be diagonal matrix. But if these three become equal like this, in this case and this case, then it will become a scalar matrix. But if in case they become 1, okay, then it will become identity matrix. Okay, so this is the thing which you have to bear in mind. And now there is again one more definition of identity matrix. Okay, identity matrix or unit matrix, a diagonal. Okay, with a lot of disturbance is there over here because of traffic. Okay, so identity matrix or unit matrix, you can clearly see this thing written over here, a diagonal matrix. Okay, a diagonal matrix is called identity matrix or unit matrix if all the diagonal elements are equal and equal to 1. Okay, a diagonal matrix is said to be identity matrix. When it is said to be identity matrix or unit matrix, if all the diagonal elements are equal to 1. Okay, I have already told you all this. Okay, so you can clearly write this thing over here. Okay, I don't think there is any need to tell all these things. Okay, just a second, a lot of confusion is there. Okay, lot of confusion is there. Yes, so the way I had defined scalar matrix, the same way I am defining now an identity matrix. So you can clearly see this thing, that for I equal to j, okay, for I equal to j, that is the elements which will be present like this, for them I is equal to j. Okay, so all those will be equal to 1. Okay, and off diagonal elements, those will be equal to 0. Okay, then this a has come out to be, you can clearly see over here. What does this mean? This simply means like this. Okay, a big 0 means such is the situation. Okay, and this is the case. So all these will be what? Identity matrix. Okay, now we have something called as upper triangular matrix. Okay, a square matrix A equal to Aij is called a upper triangular matrix. It is called a upper triangular matrix if and only if. What does it mean by IFF? If means that it is necessary and sufficient condition. Necessary and sufficient condition. If and only if. Okay, if and only if. So what is upper triangular matrix? So a matrix will be upper triangular matrix if Aij equal to 0 for all I greater than j. Now you can clearly analyze this thing here. I don't think there is any need to tell this, that for this will be A11, this will be A12, this will be A13. Okay, this will be A21, this will be A22, this will be A23. Okay, and so on and so forth. If we keep on writing, then what will be this? A31, this will be A32, and this will be A33. Okay, so for I greater than j, okay, where do you find I to be greater than j? You can clearly find that this area consists of I greater than j, because general expression is Aij. Okay, general expression is Aij. So for I greater than j belongs to this area, okay, in circle. Now this area clearly has Aij equal to 0. Okay, so it is called as upper triangular matrix. Why upper triangular matrix? Because in the upper side a triangle is formed. You can clearly see that on this side a triangle is being formed. On this side a triangle is being formed. Okay, a triangle is being formed on this side, triangle of digits. Okay, so you can clearly see this thing. Now similarly, lower triangular matrix, a square matrix, A equal to, just make the definition opposite. Okay, instead of I greater than j, you make I smaller than j. Okay, so you make it like that. So what will happen? Lower triangular matrix, a square matrix A equal to Aij is called a lower triangular matrix if and only if Aij equal to 0. Okay, if and only if Aij equal to 0 for all I smaller than j. Okay, so you can clearly see this thing over here. A11, A12, A13, okay, A21, A22, A23, okay, A31, A32, A33. Okay, now what happened? For I smaller than j, where is I smaller than j? You can clearly compare it with Aij. Okay, and where do you find I smaller than j? In this area, all these regions. Okay, in these regions I is smaller than j. Okay, not this this area. Okay, not up to here. Let me erase something. Okay, let me erase. Okay, so this area consists of I smaller than j. So those elements are equal to 0 for I smaller than j. Okay, so that's all is the meaning. And why lower triangular? Because these are forming a triangle. You can clearly see this thing. Okay, which thing is forming a triangle? A triangle of digits is being formed over here. Okay, so lower triangular matrix, that is lower elements are your lower elements are non-zero. Okay, so that is basically your lower triangular matrix. So let's move on. Now we will move on towards a square matrix is called upper triangular matrix. Now this is basically your desi definition. Desi means informal definition. Okay, informal definition. A square matrix A equal to Aij is called upper triangular matrix if all the elements below the diagonal are equal to 0. Okay, why it is called upper triangular? Because below the diagonal all elements become 0. Okay, for upper triangular matrix, below diagonal all elements should become 0. So clearly you can see this thing, that below diagonal. Okay, where is the diagonal of this matrix? This is the diagonal of this matrix. Okay, so all the elements below diagonal have become 0. Okay, so let me show you properly over here. Okay, let me show you properly. After removing all this stuff, I will show you. See, okay, for upper triangular matrix, all the elements below this principal diagonal, are equal to 0. And similarly, for lower triangular matrix, what will happen? All the elements, okay, for lower triangular matrix, what will happen? All elements, let me erase this and show it to you. Okay, for lower triangular matrix, something of this kind will happen, that just have a look at this principal diagonal. Okay, so all the elements above this principal diagonal are equal to 0. So all the elements above this principal diagonal are equal to 0 for lower triangular matrix. Okay, so this is informal definition. A square matrix A equal to Aij is called upper triangular matrix if all the elements below the diagonal are equal to 0. Okay, a square matrix A equal to Aij is called lower triangular matrix if all the elements above the principal diagonal are equal to 0. Okay, so above the diagonal elements are equal to 0, and it is called as lower triangular. Why it is called lower? Because the lower side contains the digits. And why is it called upper triangular? Because the upper side contains the digits, okay, and in the triangular form, okay. See, so IFF if means that if and only if it is necessary and sufficient condition. This thing has already been told to you, okay. Now super upper triangular matrix, a square matrix A equal to Aij is said to be super upper triangular matrix. Now instead of this, I have one more thing. You can clearly see this, that we are talking about super upper triangular matrix, okay. So what will the super upper triangular matrix look like? A square matrix A equal to Aij is said to be super upper triangular matrix if Aij equal to 0 for all I greater than equal to j. Now let us consider this. Assume that this is A12, A11, A12, A13, okay. Let me write properly, okay. Let me write properly. Suppose this is your A11, okay. This is your A12, this is your A13. Then this is your A21, this is your A22, this is your A23, okay. This is your A31, this is your A32, and this is your A33, okay. So super upper triangular, what is the difference between upper triangular and super upper triangular? For upper triangular matrix, I greater than equal to j was not there, it was only I greater than j, okay, for upper triangular. But for super upper triangular, it has become I greater than equal to j, okay. So additionally diagonal elements will also become 0, okay. Aij equal to 0 for I greater than equal to j. Now you yourself have a look, where is I greater than equal to j, okay. So for this area, okay, for this area the I value is greater than equal to j for this area, okay. So in this area all the elements will be equal to 0, right? So that's the thing. So this is basically your super upper triangular matrix, and a triangle is being formed over here again. A triangle is being formed over here again, okay. What happens in upper triangular matrix? In upper triangular matrix these elements are non-zero. In upper triangular matrix these elements are non-zero, okay. But in super upper triangular matrix, even these elements, principal diagonal elements, will also become 0, and only these elements will form a triangle, okay. Got it? So that is why it is being called a super upper triangular matrix, okay. So we are towards the end of the class. Now super lower triangular matrix, a square matrix A equal to Aij is called super lower triangular matrix if and only if Aij equal to 0 for all I is smaller than equal to j. Now this is very just opposite of super upper triangular matrix. Just opposite means instead of I greater than equal to j we have this. Now you can clearly see this thing A12, अरे यार मैं A12 क्यों लिख रहा हूँ, A11, okay, A11, A12, A13, A21, A22, A23, A31, A32, A33, okay. So Aij equal to 0 for all I is smaller than equal to j. Now look at the figure and tell me where is I smaller than equal to j. You just compare all these elements with Aij and tell me where is I smaller than equal to j. So clearly this area consists of I smaller than equal to j. Either they are smaller, either I is smaller than j or it is equal to j in this area. So all these elements have become 0, okay. So these elements are 0 and these are non-zero. So it is super lower triangular matrix, okay. Super lower triangle, because over here triangle is being formed. So super lower triangular matrix, okay. Now we have two notes over here. A diagonal matrix is both super upper and lower triangular matrix, okay. What is a diagonal matrix? You can clearly see this thing, that a diagonal matrix will look something like this, okay. Okay, it will look something like this, okay. Diagonal matrix will look something like this. So it is both upper and lower triangular matrix. Why it is both upper and lower triangular? Because you can see this thing that this forms upper triangular matrix. What okay, so you can clearly see this thing. Let us go back to the slides. Okay, so let's see over here. Okay, so clearly over here it is both upper and lower triangular matrix. You can see. Okay, what does this mean? You can clearly see this, that it is 0 0 0 0 0 0. Okay, so it is clearly what condition? I greater than j will also apply, and I smaller than j will also apply. Okay, so it will become I equal to j. Okay, so only these elements will be non-zero. Got it? So it is basically both upper, because on the upper side also a triangle is being formed, on the lower side also a triangle is being formed. Okay, so they are both upper and lower triangular matrices. Okay, so you can clearly see this thing, that a diagonal matrix is both upper and lower triangular matrices. A null matrix is both super upper and super lower triangular matrices. These things these are very, very important while solving the problems. Okay, these two concepts, okay, you have to keep on your fingertips, these two concepts, that a diagonal matrix is both upper and lower triangular matrix. Okay, and a null matrix is both super upper and super lower triangular matrix. Okay, these two things, just note it down in your notebook and keep these two things in mind. A diagonal matrix is both upper and lower triangular matrix, and null matrix is both super upper and lower triangular matrix. These two concepts you will have to think, keep in mind. Okay, always. Okay, so thank you very much. जय हिंद, जय भारत. अपना ख्याल रखें.